Welcome back. In this video, we're going to cover sketch constraints. This is one of the most important tutorial videos that I'm going to do. Sketch constraints are the rules that your geometry must behave by. So if we take a look at our first one here is coincident. Again, we've got the flyouts, which are really nice to kind of give you a little bit of a preview in case you forget which dimension or which constraint does what. So here we can see we've got an example of a circle with looks like a spline segment or an arc, and then we want to make that coincident to it. So coincident basically means that 2 points share the same location. So for example, if we let's draw a line, and let's go with 155 and 1 inch. And now I draw another line. Sometimes, a lot of times what will happen is you'll click over and you'll realize that, oh no, that's not where I wanted it to go. So if we use coincident, we can say that this and this have to share the same point. It doesn't just matter, it doesn't just work, I should say, with lines. So if I have an arc, let's say, and I want to make a tangent arc tangent to this, it's going to automatically do that. But then let's say I want to make one more arc segment down here that is not a tangent arc. But I realize that I mispicked my point, but I've got this drawn correctly. I can put in a coincident constraint and it makes those 2 points share that location. Next up is collinear. Collinear basically means that 2 things are aligned. So let's just say for the case of this, I have this line up here, and I have another line over here that's going to start at my origin. Let's make this 145 degrees. And I want this line and this line to be parallel to each other, but not just parallel, but to be lined up so that this is almost an extension of this. I can use collinear, pick this line and this line, and if we think about which line's going to move, it's got to be this one. This is going to rotate. You can see that they're not parallel, and if I stretch this out a little bit more, you can see they're even that much less parallel. So if I apply collinear to these 2 line segments, now when I move this, it will not move anywhere but in line with this. Now I can dimension the distance between my 2 points. I can also dimension the length of my segment, and now this will move. Why? Because I don't have a dimension on here. When I put a dimension on here, how will this move? It won't. Now how do I change the angle of this? I change the angle of this based off of this, which is driven by this dimension here. So if I change this to, say, 150, everything's going to move. Next is concentric. Concentric basically means that 2 objects share the same center point. So let's see what happens if we have an arc here and we have a circle, and we say that these 2 things are going to be concentric. Now they share the same center point. This works with arc segments. It also works with 2 circles. So a lot of times we'll see this command being used when we're sketching things that are 2 circles. The padlock is fix. It basically makes something not be able to move. A lot of times we'll use this if we've got a reference that is kind of floating off in space, but we know it's where we want it to be. Don't use this one a whole lot. A lot of times what we'll use this is if we're picking 2 things to put constraints on, and the one that's moving is not the one that we want to move, we'll go ahead and we'll pick fixed. Parallel is next, and parallel is very simple. It means that 2 things have the same angle. Much like collinear, but with collinear, they have to be an extension of each other along the same line, the same axis. These don't. So now, regardless of what I do, if I rotate, let's say this line here, select my center point, and I say it's constrained to another geometry, now it won't let me have that constraint maintained. So this will allow me to maintain parallelism between those two line segments. Perpendicular means they come together at a 90-degree angle. So for example, if I have a line here that I know is horizontal and I have a line here that is not, I can select perpendicular, and I will make those two then perpendicular to each other. A lot of times this one's used when you're drawing in a line segment and it is off its angle a little bit. It's just an easy way to go ahead and fix that. Horizontal and vertical. So if I have a line here that's not quite horizontal, but I want to make it horizontal, I can select that. Look at the preview that I get. A lot of times this will happen. I'm not quite sure why it does happen, but sometimes you'll say, well, I know I want it to be horizontal on my screen, but it goes ahead and it tries to make it vertical. So watch that preview. Same thing with vertical. It gives me a vertical preview so I can push it either way, and then that has a constraint on it that says that it has to be vertical or horizontal. Tangent is next. So if we draw a circle and we draw a line segment, so this line is not tangent to this circle. Tangent means that a line or arc or circle is only coincident at one point. Here we've got 2 points, so we know that these are not tangent. So if we put a tangent constraint between those two, now no matter what I do with this line, the circle always maintains that tangency, and it moves around a lot because I've got 6 dimensions that I need down here. Smooth is one that we don't use very often. It is used with curves, so we'll cover that more down the road. Symmetric is one we use a lot. Again, when I do a slot, I put a point on this side, I put a point on this side. I can now dimension those 2 points. Let's make this a 3-inch dimension. And now we see that they are clearly not symmetric. They could also be shoved off to one side. So this line is not anywhere in between those 2 points. Symmetric constraint. I'm going to say this a lot when I demo, when we make parts. I just say it a lot when I'm teaching. I'm going to make this and this symmetric about that. And now this is my line of symmetry. Okay, so if you're thinking, what is it asking for? Notice down here, it says select first sketch element. Well, that really doesn't do me a whole lot of good. So I want this and this to be symmetric about that. So my line of symmetry is the last thing that I pick. Now, no matter what I make these, they are going to be on each side. They're going to have the same dimension. And then equal is the last one, and basically that sets 2 things to be equal to each other. So if I have, for my example down here, I had a circle. Let's make this 1. I have a circle over here. We'll make it smaller. If I make these 2 equal to each other, this and this, it's going to make this one larger because this already has a dimension on it that can't be changed. If I were to, let's do this, make this smaller. How about we just undo? Take this dimension off, do an equals constraint, this and this. It is going to be based off of just random. So if you know that you need to have a size, go ahead and do that. If you're at this point and you've already put the constraint on, it's not that big of a deal. We can dimension this, and since they're both the same, now they will change. Now if I dimension this, what happens? Think about it for a second. What should happen is I should get an error message that says it's going to over-constrain the sketch. Over-constraining means it can't solve it. And so we're going to say except, and now we get what's called our driven dimension. And that is going to show us the result, how big it is, without, knowing that these two are tied together. So for example, if I'm working on a project, I go on vacation or I'm at a conference or out of the office for whatever reason, and a colleague looks up my part and says, oh, I can see now that this and this are tied to each other. We can also hit F8 to show our constraints, and then we start to see our symbols. What's nice is when I hover that symbol, it will show me the geometries that are related. So here, if I hover my symmetric symbol, I see my line of symmetry changes color and my 2 points get the little X on them there. So that's pretty nice. And then F9